Welcome to Clean Code in the Browser. This is episode 5, the interface segregation principle. Don't mind this, I'm just finishing up a deployment. Don't worry, I'm an excellent multitasker. In the last episode, we spent time considering the differences between complicated problems and complex problems, and we used the Cynefin framework in order to determine the best approaches to each of them. Hold on one second, this might be important. Hello?
Hey, so I just finished the code to change all the bebobs to flea-flobs and the whammers to jammers. I gotta get this out quick. Can you take a look at the PR ASAP?
Oh yeah, I can do that. I'm in the middle of a deployment and something else, but yeah, we can do that. I'm a pretty good multitasker. Oof, this patch is a mess. I better leave some comments. Oh, sorry. Let's see here. So after the Cynefin framework, we then talked about the Liskov substitution principle and how we can use that to make sure that we're not accidentally breaking the agreements between our objects. I'm sorry, I need to take this. Hello?
Hi.
This is your boss. We've got a bit of a problem, okay? I put in a high priority ticket to Jira. I'm gonna need you to take a look at that ASAP, okay? Thanks.
Yes, sir, I can definitely do that. I am moderately decent at multitasking. All right, thanks. Okay, let's see what we got here. Jira. Oh, well, there's your problem. Somebody put a flooper where a glooper was supposed to be. Rookie move. Although I should probably check the deployment first. Oh, sorry. So we wrapped up the last episode by looking at how the Liskov substitution principle was still applicable, maybe even more so when you're using a dynamically typed language like JavaScript rather than something that's statically typed. Just because the types and interfaces aren't explicit doesn't mean that they don't exist. They really do, it's just they're much harder to reason about. And speaking of, I can't seem to reason about half of this code in this pull request. Although I should probably resolve this bug first. But check on the deploy. But you probably want to know about this episode. Fair enough. So for today, we're going to be talking about the I in Solid, the interface segregation principle, which again might seem a little strange seeing as JavaScript doesn't have interfaces. So we're going to look at how the interface segregation principle allows us to create many client-specific interfaces rather than one big general interface. And we'll see how that brings us benefit even in a language like JavaScript. Now, what was I supposed to be doing again? Look, I'm a little busy. What do you need?
Oh, you think
You're busy. Well, I'm the one who is taking all the flack for the things that you are screwing up.
hello?
Mr. CTO, sir. How nice of you to call. How are you?
Cannon powers.
There is already enough BS without you opening your mouth. I've got people sitting around waiting for pull requests to get reviewed. I've got clients chewing me out because that bug still isn't resolved. And by the look of these Nagios graphs, I would say that your deployment just broke the app. What on earth is going on over there?
Oh gosh, I'm sorry. I guess I'm not very good at multitasking. Like at all. Some of my first experiences with multitasking came from playing percussion. Growing up, I was a percussionist in concert bands and orchestras. In any given piece of music, there were probably pieces for 5, 10, even 20 different percussion instruments. Thing is, we didn't have 20 percussionists. We hardly had 5. And so it was up to each of us to run around the percussion section, sometimes literally, in order to play each instrument. Composers love to sprinkle percussion into their piece just when they need that special oomph. It's not unusual for something like a tambourine to only play a couple notes in an entire piece. Now, a composer can probably only write 4 or 5 simultaneous percussion parts, but across the entire piece, they can ask for as many different instruments as they want. So it takes a lot of coordination, but ultimately multitasking with these percussion instruments works. Skilled percussionists can get to here and there without breaking a sweat. Well, not much of a sweat. This kind of multitasking is all about optimizing for busyness. It would be very expensive if we had to hire 20 percussionists to each have them only play a few notes in any given piece. You have to pay a percussionist the same paycheck, whether they play 1,000 notes or just one, so you might as well get as many notes as you can. And to be honest, the percussionists prefer this as well. There is nothing worse than standing perfectly still for 10 minutes, waiting until finally your part comes, and then the piece is over. Staying busy makes a percussionist feel valuable. Staying busy makes a percussionist feel skilled. Now, you have to realize that playing concert percussion, it's not really a creative task. It's mostly technical. The sheet music in front of you tells you what to do, and you do it. To reference the Knephen framework from last episode, this work is complicated, but it's not complex. Multitasking works in this context because you can plan out all of your tasks linearly. The rules start to change, however, when you move from concert percussion to the drum kit. With the drum kit, multitasking is taken to the next level. Rather than running between different instruments like a crazy person, you play all of them at the same time, like a crazy person. There's an excellent Clean Coders video series by Mark Seaman called Humane Code. In it, he talks about how the human brain can only keep 7 ideas in it at once. Only 7. Now, at first blush, it might seem like playing the drum kit is well below this maximum. I mean, I only have 4 limbs. That leaves me 3 more things to think about, like a grocery list, repainting, and solving world hunger. But that's not quite right, because it's not how many things can I think about at once, but how many pieces of information can I focus on at once. For example, my right hand alone needs to think about which instrument am I going to hit, where on that instrument am I going to hit it, how hard, what rhythm am I playing, and what's the tempo. That's 5 out of 7 just for my right hand. And this is why abstractions are so important, both in music as well as in code. Those abstractions give us an opportunity to think at a higher level. Abstractions allow us to think about complex subjects in simple terms. It allows us to think about bigger items than would normally fit into those 7 slots in our head. And without abstractions, it would be impossible for us to enter flow state. Flow state. Some call it being in the zone. It's a state of intense concentration and immersion. That feeling when you lose track of time, of your surroundings, of yourself. You feel powerful, capable, filled with clarity and agency. Some people experience this feeling in their work, some in their hobbies. Runners describe the feeling as the runner's high. Or so I've heard.
Crap!
water. I'm not gonna make it. I'm really not much of a runner, like, at all.
Medic! We need a medic! Oh, wait. Oh, it's just him. Yeah, never mind. As you were. So back in 1975, flow state was first identified and named by Hungarian psychologist Mihai Csikszentmihalyi. Let's spell down here in case if you were curious. Flow state is a psychological phenomenon one experiences when they have deep concentration and focus on the particular work or task they're doing. We've all experienced it at one point or another. You have such a level of focus that you actually start to lose sense of time passing and of self-awareness. You might just blow right through lunch, for example, because you didn't even notice. You were so completely engaged with your task. There are many benefits to being in flow state. One of them is productivity. When we're that engaged and that focused on our work, we can do a lot of high-quality work in a small amount of time. But perhaps the bigger benefit is that flow state feels very rewarding. It's satisfying to have that level of focus on something, and that satisfaction comes from the work itself, not just from the end product. Flow state is triggered by intrinsic motivators, and interestingly, it also acts as an intrinsic motivator. Intrinsic motivation is when the work feels inherently meaningful and motivating. Now, this is the opposite from extrinsic motivation, which relies on the promise of rewards, like a raise or promotion or a bonus. In his celebrated book, Drive, author Daniel Pink talks about 3 factors that fuel intrinsic motivation: autonomy, mastery, and purpose. Let me get changed, and then we'll talk about each of them. So first, autonomy. Autonomy means that I have the agency in order to make the decisions and take the actions that are needed. I'm not blocked by third parties. I don't have to run everything by my boss. I can just make it happen. When I don't have that autonomy, I'm right back to multitasking. Trying to get stuff done, while trying to get all the approvals that I need, while trying to get through all the blockers that are holding me back. Flow and focus are gone. All right, this is really starting to come together. Now I just need to associate some of these objects and then, I just recently finished a book. It was by a gang of some type. It talked a lot about the visitor pattern, and I think we should probably, definitely use the visitor pattern here. Okay? Okay, well, I'm not exactly sure how applicable that is to the situation, but I'll keep it in mind. Anyways, should be able to just wrap up the last few lines here, and then we'll be able to... I see you typing a lot of semicolons at the end of each line. I just finished reading an article about automatic semicolon insertion, ASI. And frankly, I'm not sure why I'm paying you to type in semicolons that JavaScript was already going to put in. No autonomy, no go for flow. The second intrinsic motivator is mastery. Mastery means that I have a very high level of skill in my craft, but it also means that there is clear benefit to continued growth. Now, having proficient skill alone, it's not enough to trigger flow. You also need a compelling challenge. Now, the sweet spot is when you have high skill and high challenge. That's when flow kicks in. This is so hard, but I'm so good. I'm in the flow state, baby. Whoop whoop. Whoop whoop. When you have high skill but low challenge, you're gonna crush it for sure. It might feel fun, it might feel relaxing, but it's not engaging enough of a task to trigger flow. Ha!
Another FizzBuzz bites the dust. Nobody can do FizzBuzz as well as this guy. FizzBuzz champion! Now that certainly is preferable to having high challenge and low skill. In that case, you are in way over your head. There is nothing but anxiety and worry waiting for you there. Okay, well, I can really tell that you are going to love the new project. It really is the new hotness. It's got machine learning, emergent algorithms, everything that you could possibly want. But I normally do CSS and maybe a little HTML. I don't even know how to... Sounds like a perfect fit. Go get 'em, killer. Oh, and I'll need it by Monday. Thanks. Please, send help. So finally, there is low challenge, low skill work. You probably don't feel that compelled to work on it, and frankly, it probably wasn't all that important to begin with, and so you end up with apathy. All right. So low skill, low challenge, and apathy. I was born for this work. Both mastery and challenge are two key intrinsic motivators that help us unlock flow. The last intrinsic motivator that we're going to talk about is connection to a strong purpose. Working on a project that is personally meaningful to you is an intrinsic motivator. This is the kind of stuff that you would be working on even if you weren't getting paid for it. Anytime that you are well aligned with the project that you're working on, your ability to deeply focus on it increases. When you're not well aligned, you're always being pulled in two different directions. Perhaps asking yourself, wait, why am I working on this again? Now, don't get me wrong. I'm not saying that you have to be saving the manatees or solving poverty in order to establish flow. I mean, most of our work and our hobbies, frankly, are not that noble. So maybe you find the project fun, or you're interested in the technology and the stack, or maybe you just think that there's a strong chance of success at the end. I find flow state while I'm painting. It is fun, it's challenging. I definitely like the end product, but that's about it. Your reasons are your own, but whatever they are, it's the connection that matters. You have to value the work itself and feel connected with the outcomes. So now that we have a working knowledge of flow state, it becomes very obvious that multitasking is the exact opposite of everything that you need to get into flow. Flow requires a period of uninterrupted time for deep focus, but multitasking has you jumping all over the place from task to task. You never have a chance to enter that deep state of focus. Flow requires that you have autonomy, but multitasking demonstrates that you don't have that autonomy. If you did, you probably wouldn't be multitasking. You would be prioritizing and doing one thing at a time. But instead, you're stuck trying to do everything that everyone asks you to do all at one time. Flow requires mastery, but multitasking only wants busyness. As long as we're staying busy all the time, there's never any time to pursue mastery. And flow requires strong purpose, but multitasking by definition is aimless. While we're trying to do everything at once, we're failing to prioritize, and so we can't connect to one strong purpose. And so, for the sake of you as an individual and the organization that you're working in, I have one request. Please stop multitasking. Wait, stop multitasking? Yeah, just don't do it. Just stop. Just stop? Huh. I never really thought about that before. I mean, can I really just stop? Of course you can! Oh no, you cannot! You get right back to multitasking those 7 top priority tasks right now. And you, I don't know what kind of hippy-dippy new age kind of snake oil you're peddling, but my company will have none of it.
Huh. Interesting. I guess I would have thought that your staff's well-being and motivation would be of top concern to management.
I'll have you know that we take great care of our people. Hey, Jimmy! Less gabbing, more tabbing! Or more spacing. Whatever is popular in medium think pieces.
Well, if the hippy-dippy benefits don't interest you, what about productivity increases? What would a productivity increase be worth to your organization?
Yeah, productivity increases would be amazing. I'm ready to pay. What are we talking? Perfect. Well, the price of this productivity increase is prioritizing your projects and only working on the first one until it's done. Don't start the second until the first one is done. I don't get it. You said we would see a productivity increase, but now you're telling me we can only work on one project at a time. That's doing less, not doing more. Yes, exactly. We do less to get more done. Here, maybe this chart will help.
Let's say you have 3 projects, and you think each will take about a month. When you multitask, you think it will go like this. After a month, maybe a little more, all 3 projects will be knocked out, and everyone will be heroes. Exactly. The team will rise to the occasion, work at 100% utilization, and knock it out.
But here's the problem. Working on multiple projects is not like playing the drum kit. You can't seamlessly transition between them. There's no groove between them. There's no abstractions across them. Instead, it's like concert percussion. Every time that you switch tasks, every time that you change projects, it's kind of like running from one end of the stage all the way over to the other. It's costly, it's confusing, it's context switching. You can't effectively contribute to many projects at once, and every time that you context switch, you're wasting time. So really, our project plan should look much more like this.
Wait, that looks terrible. The timeline just went from 1 month to 4 months. Put it back the other way. I'm sorry, but that's just not realistic. When we run all 3 projects at once, they all take longer than they should, and none of these projects provides any user value or feedback until they are all done at the end. Honestly, this is tragic. It's a waste of time, money, and talent. And why? Also, no one had to make a hard call about which project is most important. But what if we change the circumstances? Let's say the management gets some cojones and decides the project 2 is the most important thing, followed by project 1, then project 3. The team decides to do less in order to get more done, and they focus on that highest priority project all the way through to completion before moving on to the next one. Let's see how that affects things. Wait 1 second. Before, it was taking almost 4 months to get the projects done, and now it's much closer to 3, even though we're not multitasking. Exactly. And it makes sense. The work hasn't changed. We still have to solve the same problems and build the same software. The difference is that we're no longer wasting time context switching. Instead, we are fully focused, reducing the cost of collaboration and enabling flow state. Well, okay, I see your point, but it only saved a couple of weeks. Not true. Yes, the lowest priority item still took over 3 months to ship. However, the highest priority item shipped after only 1 month. That's huge. The team is getting real user feedback and making real money 2 months sooner than when we were multitasking. That's better for your users, better for the bank accounts, and better for your team. Focus and Flow are incredible tools for creating engaged teams that ship early and often.
So talk about this stuff with your teams. Don't accept the status quo of multitasking just because it's how we do things. So read up on flow state. Learn more about the values of reducing work in progress and your lead time. Take a look at the Kanban values and see how they might be applicable to your team. And above all else, just stop multitasking.
Okay, fine. Twist my arm already. Jeez. Just, some of us happen to like the status quo. Just saying. Are you tired of running out of paint at the worst possible times? Boy, am I ever! Do you regularly make the mistake of ordering too little paint to restock?
Not again.
Or do you accidentally buy way too much paint instead?
Looks like I went overboard.
Well, good news. Here at BigCorp, we understand that painting is hard, and managing your painting resources is even harder. That's why we are announcing our latest SaaS product, the Painttastic 2000, to make your lives easier and to make us a lot of money.
Why, this software is so easy, even an evil genius could use it. And so can I!
Call now.
Thanks to the latest ad campaign, the Painttastic 2000 has been selling like hotcakes. Assuming that hotcakes sell well. It's actually been a while since I've looked at the data. Anywho, it's been good for business. I got a new chair. We hired a couple new developers. Hey, Jimmy! Jimmy, take the phone call out into the hallway. Jeez, this guy. There's really only one problem. Now the bosses are convinced that they're product geniuses, and these feature requests are coming in faster than ever. Our code is starting to bloat fast. First, they came in and said, yeah, I'm gonna need you to allow free trial users to try out the app free of charge for 2 weeks. And don't make them go through all that login rigmarole. Why don't we just send them a link they can click and they're logged in, okay? We are going to make so much money! So, I implemented that functionality in our user class. And just as I was about to push to master, they came back. Yeah, I'm gonna need you to allow any of our employees to log in as an admin user. They should be able to then log in as any other user for troubleshooting and for customer service. Okay. Oh, and make sure that you use our LDAP server to authenticate our admins. We want this to be perfectly secure. We are going to make so much money! And so, my user class got even bigger with all of this admin functionality. I don't know what to do. I mean, I tried locking my door, but they have a key. So it sounds like the system is expanding rapidly, and perhaps the old abstractions that you started with aren't keeping up with the new growth. If you're seeing your user class bloat substantially, do you think you might have a single responsibility principle violation? Well, I did think about that, but I don't think so. It's complicated because our database has one huge user table, and so my code ends up having one huge data access object. Oh, tricky. So unless if your DBAs can make a big change, you're going to continue getting big chunky user representations from the database, and your application code reflects the same structure. Exactly. And it's only a matter of time until the bosses get their next big idea. I'm so scared. Oof. Well, this sounds like an excellent opportunity to talk about the interface segregation principle. So I don't know about you, but my garage is a complete mess. There are tools strewn about, kid stuff all over, bins full of seasonal clothes, random piles of insulation left behind from the previous owner, yard games, holiday decorations, furniture, bicycles, homebrewing equipment. I think you get the idea. So let's just say I want to get my act together and get this place cleaned up. Everything should have its place, everything should be organized. But how would I actually organize all this stuff?
I know. We could organize everything alphabetically. Things that start with low letters go over here on the left. All the things at the end of the alphabet go over on the right. Piece of cake.
Sure, yeah, that could help in many circumstances. If you knew exactly what you were looking for, and you knew what the right name for it was, then you should be able to find it very quickly alphabetically. Unfortunately, discoverability suffers. Finding related items would be very hard because they would be spread out all across the garage. And heaven help you if you forgot about something. You may never find it again.
Okay, well, if you want to optimize for finding similar things, maybe we could organize by season. Yes, we could put all the winter stuff over here, and spring, summer, and fall stuff way over there. Nailed it.
Yes, that would actually make it much easier to find all your holiday decorations or all of your summer clothes. They would be stuck in one spot together rather than being spread out all across the garage.
Oh yeah, I did it. I rock. Martha Stewart. Oh yeah.
But what about the tools that I use year-round? Where would those go? And if we organize it into seasons, I mean, a season is a quarter of the year. There's a lot of stuff in there. How could I find the one thing I'm looking for in that big pile?
Look, I kind of feel like you're just stringing me along here. Why don't you just tell me the right answer?
Okay. Well, what if instead of organizing things around seasons, we instead organized everything around the people who were actually looking?
Go on.
Something I noticed about this garage is that the stuff that I need to access is totally different than the things that my wife needs to access, which is still different than the stuff that my kids need to access. When I come in here, I'm usually looking for landscaping stuff, tools, maybe some homebrewing equipment. When my wife is in here, she's probably looking for seasonal decorations and wardrobe. My kids, on the other hand, are usually looking for their bikes, toys, or art supplies. The Venn diagram of our interests pretty much looks like this. Very little overlap. By separating out the things that I care about away from everything else, I reduce the mental overhead of trying to find something in this garage. I just have to grok my own stuff, and everything else doesn't really matter. Now, in a perfect world, I would have my own garage for my own stuff. Then my wife would have a second garage for her stuff, and heck, we'd get a third garage for the kids. All of our things would be highly decoupled and very easy to understand.
Oh, and I guess you would each probably have your own magical ponies as well, and you could have tea and crumpets with them. Idiot.
Now, obviously in the physical world, I'm only ever going to have one garage. But in code, we can have as many garages as we want. Let's chart this out. In this example, the garage object has 3 clients that use it: my wife, the kids, and me.
The garage is offering a single general interface to all three of us clients. Each of us has access to every public method the garage offers and the responsibility to understand them, even though each client is only interested in a subset of those methods. The interface segregation principle tells us that multiple client-specific interfaces are better than having a single general interface. In other words, give each of your clients their own garage. Here, you can see that there are 3 new interfaces, each specific to the client they serve. They only include the methods that each client cares about, no more, no less. This dramatically reduces the scope of knowledge the clients need to interact with the garage object. A new developer on one of these client teams, for example, would ramp up much more quickly on the project because they didn't have to understand the entire garage class. Rather, they only had to grok the smaller surface area of the client-specific interface. Now, this technique works best when the clients have different interests and very little overlapping functionality. But it is possible to take a popular method and make it available across multiple interfaces. For example, everyone in the family likes to use the garden hose. I might use it to spray down the deck, my wife might water some plants and flowers, and my kids certainly enjoy running through the water. Let's see what this does to our design. Since all the clients need the garden hose method, it is exposed through all the interfaces. Interestingly, the garden hose implementations might be identical, or they could be different behind each interface. The important part is that the implementation detail is hidden away from the client. They neither know nor care. All they know is they have a garden hose to use, full stop. So the interface segregation principle says that many client-specific interfaces are better than one generic interface. So let's check back in and see how we can apply this idea to actual code. So now that we have a shared understanding around what it means to create segregated interfaces, how do you think that you could use this in order to improve your code?
Okay, yeah, I think I'm starting to get the hang of this. So I have a huge user data access object that sometimes represents an admin, sometimes a free trial user, and sometimes just a plain user. The admin parts of my code don't care about free users or plain users. They really only care about the admin functionality. And the free trial upgrade part of the application doesn't care about admins or plain users. It only cares about free trial functionality. So I should be able to create client-specific interfaces in between the big user data access object and the code that actually uses it. Here, take a look.
The admin section code now has an admin user interface that offers the LDAP username. The upgrade page code has a trial user interface that offers days left in trial. Finally, everything else uses a member user interface that includes an address. Anything that is common, like the user's name, is made available in each interface.
Yes, that is perfect. While you may not be able to change the fact that you have a giant data access object in the system, you are now protecting other teams from that knowledge using client-specific interfaces. Cool. Though, there is one big problem. I'm using JavaScript. JavaScript doesn't have interfaces in the language. How am I supposed to use the interface segregation principle when I don't have interfaces?
Yes, please, do tell. How do you create interfaces with a language that does not support interfaces? This should be rich.
Hey, cut it out. Look, it's a great question, and it's not obvious. The good news is that we have a few different things that we can try. So let's jump into the code and see what we can do.
All right, so imagine that this user class is really big. Let's say this is hundreds, thousands of lines long. This is just a small excerpt that we can actually work with for these examples. As we saw in the previous diagram, we have a user class, and it has a number of different concerns mixed together. We have address, which is something that would be used by the members. We have days left in trial, which is used by trial users. LDAP user, which is something used only by the admins. Name, which is something that would be used by everybody. And then a few helper methods here in order to do some formatting. Now, to make sure that everything is working correctly, of course, we have a test. Now, the test, we've already gone ahead and created 3 distinct different blocks to describe a member user, where we say that we check to make sure it provides a name, it provides an address, and it provides an address that has that second address line in it as well. We have an admin user that provides a name and provides an LDAP username. And we have expectations around the trial user, who, again, provides a name, but also provides the number of days left in a trial. Now, what you'll notice currently is that we are creating a new user object with the information that we expect to have for each particular kind of user. But that is what we are basing all of our expectations off of. The subject of each of these tests is the user that we're creating. Now, when we create new client-specific interfaces to use, we're going to be changing what the subject is. A handy trick here is to use something like this.subject so that when I change what that is, I don't have to go in and change every single test. All of these tests are going to stay the same. We like these assertions and they should still be there. The only difference is what the subject is going to be. We won't be directly talking to the user class anymore. Instead, we will be talking to some kind of interface that we're going to build out. So before we start this refactor, we do want to start with our tests and making sure that they pass, because if we're doing a refactor without passing tests, we're not really refactoring at all. We're really just changing stuff. Good news here, our modest number of specs do pass, and so we are ready to do some refactoring. I want to start our refactoring by pulling the member user functionality out of the user class. And the first technique that we're going to try doing this with is extraction. What I want to do is I want to slim down the user class by literally pulling functionality out of it and putting it into a different class. It'll act like an interface in that all of the member-specific user functionality is going to live in a member user class. That way, if I know that I need a member, I'm going to use the member user class. If I need to use something else, then I'll use that. All of the member user functionality will exist in the member user class, and any shared functionality will need to be there as well. Let's see what that might look like. So I'm going to create a new class called member user. And the constructor is going to take a user. So I'm going to stick with the original user here because remember, this is kind of an interface on top of user. This is something that is going to sit between the calling code and the big user class. Member user is kind of in the middle. So you can imagine member user kind of wrapping itself around the user class and functioning kind of like an interface. So I'll say that this user is going to equal the user. And before we go changing anything else, let's go over to the test. And my member user test here now, I want to make the member user something that gets exported. I'll say that user.member user equals member user. I should mention, by the way, that normally these would all go in different files for the sake of this demonstration. We're going to just keep it all in one file to keep it simple. So in my test now, I want to access member user. And now when we create our subject, rather than just using the original user as the subject, what I really want to do is to create a new member user, pass the existing user object in. And now my expectation is that the rest of this will just work. I'd like to transparently swap in a member user for where the user was being used before. So this subject .name and address should continue to work. And if we go over to the test, I am sure that it won't work. And of course not, because we're missing name and we're missing address So we need to fix that. So coming back over to our implementation file, we haven't defined these. There is nothing that tells us what name and address are all about. Address is something that we expect for only member users to have, so we can extract this out of the user class. We don't expect to miss it at all. So the data here, this is now going to be this .user.data that we want, but otherwise the rest should work fine. Let's double check with our test to see if we've fixed part of that problem. So now it's telling us that we still need this .name. Also, now this message changed. It was originally telling us that we didn't have the address function. We fixed that. But there's a helper here. There is an underscore format address, kind of a faux private method that we have inside of this user class that was being used. So now we have our first interesting problem to deal with. So format address, it's possible that this is something that was only being used by the address. And if that's the case, then we certainly could just come and drop it in here. And I think this should at least solve that one failure. Sure. So now all of a sudden that address failure is missing. So that works. But here's the tricky part. What if that wasn't true? What if format address was not something that we could extract out of our user class, perhaps because it was being used by a number of different user methods, some of which were inside of the member user class, but others which might be in other classes. It might be shared functionality, or it might just be needed for the user class itself. How do we get at that? There's a few possibilities, some probably better than others. So if we can't extract it into the member user class, we do have a reference to user. Now, this is JavaScript. JavaScript does not have private methods. And so we could do something like this .user.format address. And that should keep this passing. In fact, it is. The one that was failing is now passing. Is it a good idea? Maybe. You would have to think about this one. Now, because we don't have true private methods inside of JavaScript, we have to fake it using these kind of underscore mechanics. JavaScript is not the only language that does this. Certainly Python does as well. There are naming conventions that inform the level of scope that we intend for a particular method. So this works. It is functional, but it's dangerous. The reason why it's dangerous is that given the convention, anytime that we see this underscore, we know as developers this is something that is internal. This is something that shouldn't be called outside of the class that it's in. It should be treated as private, even if it's not literally private. So someone comes along in the code, they come to the user class, and they see format address, and they make a reasonable assumption that they can make changes to this so long as they understand the impact that changes to format address has inside of the class that has format address. This is no longer the case because we are using this outside, and it's unclear. So another thing that we could do is we could make this public. Again, in convention, if not literally making it public, by removing that underscore, updating all the references to it. This should still be passing. It is. But we've made another change here. We now move this from being private to being part of the public API. Is that really our intent? Is that really what we want? Do we want each instance of a user to have a format address function that is available to the entire world? I'm guessing probably not. I mean, it's certainly convenient the way that we're currently building this out. It's convenient for member user to be able to access it, but it doesn't make a lot of sense for this to be on the user. What would make sense is to have that format address just available somewhere, somewhere that member user can get access to it as well as other entities in the system. So what's more likely, its format address possibly might belong somewhere else in some kind of a formatting helper module, some kind of an address module, something along those lines. Maybe a new address class that knows how to format itself, a lot of different possibilities. There certainly seems like there are multiple concerns that are mixed together here in the user class. The fact that we're doing all of this formatting as well as having the data itself in the same class. This is a great kind of smoke signal that there's an opportunity to take format address and pull it out. For now, why don't we just say that we're going to lift this and put it directly into the class. And we will go back to treating it as some kind of a private function on the member user. So our tests are reminding us that we still have two failures. Let's take a look at this second one. So cannot set property address to of undefined. What's happening here is that we originally set up a user with an address, not including the address to field. We want to make sure that it is properly rendering just address 1 in this first test where we provide an address. In the second test, we are trying to reach into the data and add that second address field. The problem here is that originally this subject was a user instance and had a data field on it, whereas now we changed it to member user, it doesn't have a data field. The whole goal of using this.subject in our tests was to try to abstract away the idea of what the subject was from the assertions that we were placing on it. And I had mentioned that I hoped that we'd be able to change what the subject is without changing any of this code. And yet, it didn't quite work, not here. And the reason is because we were kind of piggybacking on this.subject. We were reaching into it to get into data, to get into address 2 and make changes there. What we really should have done is we should have had an explicit reference to that data element so that we could change data and not have the test worrying about what the relationship is between the data that's going in and this.subject, since that relationship changed when we moved over to member user. So let's change that now. If we were to take the data that we have here, and we want to pull this out and make it available as this.data. Now, rather than this.subject.data, we can directly reach into this.data and change the address to field. If we try running the test again, great, we are down to a single failure now. This.subject.name is not a function. Now, the name field is going to give us a similar set of questions that we asked when we were looking at format address and trying to decide how to extract format address and place it into member user. We know that name is something that is used across many different kinds of users. In fact, we decided that members and admins and trial users all have name of some kind. And so what do we do with it? We know that we can't just simply extract it and put it into member user because we need it elsewhere. Name definitely belongs in a user. It doesn't really belong in some other kind of module in the way that that formatting logic could have been externalized. So that doesn't make much sense. So it seems like there are two possible options. The first one is copy-paste. Maybe we would want to copy name out of user and paste it into member user and essentially duplicate that logic. In fact, let's try that now. The good news is that we should have a passing test. Let's double check. Okay, so we need to double check username, right? Because we need to update this to this dot user dot data dot username or this dot user dot data dot trial name. One more time. Okay, so now we're passing here. But I hear the alarm bells going off. We know that copy-paste is generally a bad idea. But why? Why would copy-paste be bad? Well, some pros and some cons here. So if we were to have member user, trial user, and admin user, and they were all to duplicate the name function, the question is not, well, is it dry? Is it duplicated syntax? Clearly it is, but that's not really what we care about. When we talk about not repeating ourselves, what we're really asking is, do we have duplicate knowledge? Do we have duplicate knowledge in our system, meaning that anytime we need to change or update that knowledge, we would need to do it in many places? And if the answer is yes, if the answer is that we are kind of duplicating that, well, then don't copy paste it. That's a real problem. But that's not necessarily the case. If we can't think of any reason why member user would change in a meaningful way that would impact admin user or trial user, well, then maybe it's not too big of a deal. When we look at this code here, we can see that we're checking for either this.user.data.username, or we're checking to see if there's trial name. Clearly, the trial user has some different logic than member user does. So having a separate implementation of name for trial user using this code makes a lot of sense. And in fact, we would be able to remove this from member user because a member user is never going to have a trial user name. So we can reduce it to this, which is already a step in the right direction. But member users and admin users both have a username in that data object. They both would share this logic. So the question, would there be a reason why member user would change and admin user wouldn't change? It's hard to say for sure. Maybe the schema changes. We change from username to just name. And if that was the case, you would want to update it in both places, in member user and in admin user. But you could imagine other situations in which maybe it is only changing in member user. Well, one thing that we can do is we could kind of punt. Rather than leaving this here, for the sake of being dry, we could change this to this.user.name. Now, this might look a little funny. We've created a name function that is just calling the original name function that we had. So what we weren't able to do is we weren't able to extract name fully out of user. What we have done, however, is we've created a new function, even though the contents of it is just proxying back to the old function. But it's clear that a member user cares about address, it cares about name, and apparently cares about formatting that address. That is clear in the code, and it's clear that the name of functionality is something that is not exclusive to member user. It's something that is shared, and it's something that for the time being does actually belong on that core user object. And let's take a look at the tests, make sure that we are still passing. And we are. So, in this case, we used extraction to try and extract as much out of member user as we could. And to some extent, we succeeded. We pulled a lot of that address functionality out of user into member user. But in some cases, with name here, we weren't able to pull everything out. We were able to reuse the functionality that still existed in the user class, and we still have a clear API for our developers and our users of what it is that member user cares about, and all the other stuff it clearly does not care about. Next, we're going to refactor the admin user functionality. Now, I've already gone ahead and created an empty admin user class that accepts the user instance, but it's not doing anything with it yet. We have these same assertions that we had before. And if we test them out, we see that sure enough, we are failing because there is no name function and there is no LDAP user function on this currently empty admin user class. So we can take a look at filling that out. So the admin user is, again, taking that user and we have that available. This time, though, I don't want to use the extraction method that we used for member user. Rather, let's try using a facade. So the facade pattern, similar to architecture, a facade is going to be some nice, very kind of aesthetic front that is hiding some kind of complexity, some kind of abstraction, some kind of mess behind it. So whatever is behind it might be all screwed up, but thanks to the beautiful facade that's on the front, the users of the code, or the people who are looking at this particular piece of architecture, only see cleanliness. They only see something that is pleasant and aesthetic. In this case, admin user could do something similar. The way that we would do that, we know that we need a name function. And we know that we need the LDAP user. Rather than copying and pasting these, rather than having to figure out what are the other helper functions that can move or can't move, rather than doing a significant amount of refactoring, we could do something as simple as return this.user.name and return this.user.ldap-user. Now, to some degree, this is what we did previously in member users. We kind of punted on it and we said, well, the name probably does belong at that user level, and so we'll proxy to it. But what about LDAP user? LDAP user clearly, you could say, belongs in the admin user class. But maybe LDAP user is very difficult to extract. Maybe it's going to be very difficult to kind of nail down. By taking this approach, we solve some problems and we cause some problems. The problems that we solve is that we just created this class in 30 seconds because there was hardly anything to it. In fact, there was kind of nothing to it. All we did was we are proxying back to the original user. We have just created a facade on the front. So we give the appearance that there is an admin user that you can use that has kind of the logic that needs to be made available, when in reality, it's just proxying back to the mess behind it. There is value in this, though, because part of what we were trying to do with the admin user is create this interface. We knew that user was big and nasty, and we didn't want our developers to have to understand the entire thing, so we wanted a new interface. Admin user provides us with that interface. It gives us a very clean API. We can call name and LDAP user, and that's it. Nothing else is going to go through. We don't have access to any of the other stuff that user offers. Now, that said, we didn't slim user down at all. We didn't remove any code out of it. We didn't actually streamline the user class itself. So why would you use this pattern over the extraction pattern that we had before? One big reason you might use this is if the class that you were trying to extract from is just too big, too hairy, there's too many intermingling dependencies to be able to cleanly and clearly and safely pull things out and extract them. This is a very fast way of creating a facade in front of a big, hairy, nasty object if the goal is to create a very clean, simple API. If that's the goal, then we've definitely succeeded. But if the goal is to really slim down that big hairy object to kind of dismantle it, then we should put in more work, more time, probably more tests, and use something like the extraction pattern. Now there is a problem that both member user and admin user have that we haven't talked about yet. So far in these examples, there's only been a few different functions, and so copying them into the other classes hasn't been a big deal. But we are trying to imagine that there are hundreds of lines or thousands of lines in the original user class. What if member user still needed to access 10, 20, 30, 40 of those original methods in user? And what if those are shared in such a way that we need to do things like this, where we are proxying back? Or certainly with admin user when we were using the facade pattern, where all of them are kind of proxying back. After a certain number of these functions, it starts to be a real drag to have a file with 30, 40, 50 of these kinds of functions in it. And if things are added over time, there's now a maintenance cost to go back into all of these other user classes and add the functions there as well. This has a cost, and depending on the situation, it may or may not be an actual problem. But for the trial user, let's try one last different approach that addresses this problem directly. So the last technique that we're going to explore for creating interfaces in JavaScript is actually using classical inheritance. So for our trial user class, let's try that. I'm going to create a new class called trial user. And for now, I'm not going to put anything in it, but we are going to have it extend from the user class. We're going to need to hook this up just so we can access it in our test. And in our test now, we'll create trial user. And in our trial user now, we want to change up, rather than wrapping user, we are actually just going to instantiate a new trial user. It is going to take this same data that the original user was getting. Let's see what our tests tell us, whether this is working yet. Okay, so it looks like I actually need to, user hasn't been defined yet. So why don't we move this up to the top just so that it is defined. And there we go. So this is kind of humorous, right? Because we have created an abstraction of some kind, a trial user, because it is extending the original user and it's inheriting all of the functionality that user has. Our tests are already passing. We have our trial user and we were able to just put it in transparently. Now it's not doing anything for us yet, but now we have some options. And in fact, what's nice about this approach is that we can very granularly move through and make sure that we are pulling out whatever we want from the original user class without breaking anything. So if we know that we want to have days left in trial, we can pull that out. And we know that this requires millis today, but let's say we even forgot about that. Maybe we knew that we needed to pull days left in trial out and put that into trial user, but we didn't even think about this.millis to days. We run the test again, still passing, because we still have access to that through the parent object. And so it gives us kind of a surprising amount of flexibility here to be able to create an interface for the trial user, where when we look at the class, we can see this is what is important to a trial user, days left in trial. And if millis to days was something that was being shared across multiple subclasses or just inside of the user class itself, it wouldn't matter. We still have access to that. And even though it's kind of a private or protected method, kind of depending how you think about it, this might still be appropriate to say that, well, our subclasses should still be able to access something like this. That would be a reasonable thing to say. And so it's yet another tool that we have. Now, there are downsides to it. One of the downsides is that the API, while when you look at the class definition, the API is pretty clear. But if you had this inside of a REPL and we're interacting with the object, the API would not be clear at all because we're still have access to all of this. And you could see what actually belonged to trial user versus what was being inherited from the user. And so it still works pretty good for defining that API and making it clear. But there's a lot that is still there. And what we haven't necessarily achieved is we haven't drawn a strong line about something like millis to days where we had to decide where this goes. In our first example with member user, we had to decide about format address. Either it belonged here in member user or it needed to be pulled out into some other kind of structure. Pros and cons with this, we didn't have to make that decision. But that means that we may not have brought the best design to this either. And over time, using this pattern, if we're not careful, you can imagine us just creating more and more coupling between the subclasses and the base class that would get harder to understand and harder to pull apart than even the original situation. So it certainly takes some wisdom, it takes some forethought to think about what are the problems that I'm trying to solve here and which of these three different approaches would actually solve it. Also, a lot of people just generally try to stay away from classical inheritance. Usually we think that composition is just a better strategy than inheritance. These first two approaches that we took were composition. We are composing bits of the original user as well as new things, and that's all composed together. And it gives us a degree of flexibility that we do not have when we are subclassing user. So these are the things that we want to be thinking about when we take this kind of approach. Do we want to have more of a decoupled approach of extraction, like member user? It makes us ask a lot of big questions early on because it is difficult to figure out what to do with shared behavior and what to do with some of these kind of helpers. Or do we kind of punt and we go with something extremely easy like the facade pattern where we define that API very clearly, but it hasn't unraveled anything really. We just tuck the mess under the rug. Or do we very easily build some subclasses in order to create some of these individual interfaces for our clients? But again, we might be creating more problems than solutions in the long run if we're not careful. At the end of the day, it's up to the developers to decide what are the problems that they're solving, what are the risks that they're willing to take, what are the constraints around that decision making, and hopefully as a team be able to decide which way we should go.
Well, I have to admit, I did work better than I thought it was going to. I mean, a little bit better.
Yeah, I mean, we're not literally creating interfaces in our code, but we're clearly seeing value from the interface segregation principle. Right. Regardless of the actual language structures that we use, we're still hiding information from the clients who don't need it, and we're offering a clean API to the information that they do need. At the end of the day, that's what the interface segregation principle is all about. Reducing the knowledge you need to interact with the system. And suddenly, here we are, back where we started. The interface segregation principle provides you with abstractions that take up less room in your head while you're trying to understand a system. The smaller the scope of code you have to worry about, the less mental multitasking you have to do, and that means less running around like a crazy person. Remember, you only have room up here for 7 pieces of information. The better our abstractions, the less we have to think about, and the more we get done. Well, all good things must come to an end.
Yes, and this episode must also come to an end.
We started and ended talking about multitasking and how disruptive it can be to actually getting stuff done. It optimizes for being busy, not for getting business results.
So I know that you said that we can fit 7 ideas in our head at once. I'm pretty sure that I top out around 3 or 4. Huh! Squirrel!
We touched on flow state and intrinsic motivators and the benefits that they offer both to the individual and to the organization. Every organization should be striving for both.
Oh, sorry. Flow state.
And finally, we explored the I in solid, the interface segregation principle. And we saw how using smaller client-specific interfaces allowed us to reduce the knowledge needed to be effective in a system.
So in related news, Chris is now in the doghouse for bringing a camera crew into his filthy garage. Rookie move, brother. Rookie move.
Yeah. Well, that's all I've got for today. You will not want to miss the next episode when we go over the 5th and final solid principle, the dependency inversion principle. I'm sorry. I gotta take this. Hello?
Help! I need help! The CTO, he's finally lost it. He's been rambling about drones and blockchains for the last 4 hours. I think he may have scheduled an ICO. So the drones will leverage a mesh network of IoT sensors and artificial intelligence to build a training set for machine learning to analyze time series cones of probability. And using multi-dimensional confluence matrices and serverless architecture, we can deliver paint to people before they ever know they're going to be an artist. We are going to make so much money! Please hurry. I can't hold out much longer. We already lost Jimmy. At least he finally shut up.
I'm gonna have to help sort this out. I'll see you next time on Clean Code in the Browser.